So we've got energy that can be in several different forms. You could do work with it by moving something, applying a force times a distance. Might be your brakes on your bike wheel, and that has been applied over a distance. We can turn it into kinetic energy. Well, coming down a hill can be turned into kinetic energy. Okay? Or instead of taking the braking force, you can, like in a Prius, you could hit the braking force and go into battery energy. Or you could take and then turn that into driving energy, and that's where a lot of efficiencies came with these newer fangled cars, is that you put your braking energy back in the battery, and then the battery would then turn it back into your moving energy, and a lot was saved. Instead of just going to heat up the car tires as heat energy, it was going back and stored energy and coming back as motion. Okay, you could turn those into gravitational energy, going up a hill, taking energy and putting it into that motion, or into compressing a spring. There are others, chemical kinds of energies, but those aren't the important ones. Those are the ones we deal with most, is either potential or movement energy. So let's go ahead and I'm going to move this to a problem where I'm going to take something that's pretty classic. I'm going to go off, and let's say I'm going to go skiing. It may not seem like the thing to do. It's pretty warm yet in California, down in your neck of the woods, but I want to go off and go skiing. And if I know at the top of the hill, I'm, for instance, 50 meters high, nothing super huge, but it's good size. And I want to know, for instance, I go down this hill, what is my velocity going to be at the bottom? I'm applying my energy from up top here, which is what kind of energy? Potential energy, right? That has a formula of your mass times your gravity times the height. You know, this is me, so I'm 100 kilograms, or the average kind of guy. Gravity is on Earth 10. That's the gravitational attraction, that's an acceleration. And the height of this is the 50 meters. Okay, that's going to go into that area. That energy, when I come down the hill, though, is all going to be, hopefully if I stay on my feet, is going to all be in potential energy. Formula for that is 1/2 my mass times velocity squared. So I know my velocity, my mass, just like I did up top, and we should be able to figure out what that new velocity is. So let's give this a little whirl. I know that the potential energy at the top is going to have to equal, because they're going to be preserved, they're going to be conserved. The conservation of energy is going to become all of the kinetic energy at the bottom. So I'm going to put those expressions in. mgy has to be equal to 1/2 mv squared at the bottom, and that's going to help me determine what that velocity is. I know what my numbers are up here. 100 times 10, that's 1,000 times 50, that's 50,000. 50,000 energy units. Joules. It's got to equal what that is down at the bottom. Well, I know my mass, again, is 100, so 1/2 of 100 times velocity squared. Well, I'm going to get the velocity squared over here. Let's kind of go, oh, you know what? Let me see if I can do this. Yeah. Always excited when technology works with me. All right, so I'm going to change the 1/2 100, which is 50, and I'm going to bring this over here, so that's going to get rid of that 50 part, which is going to give us 1,000 is equal to the velocity squared. I thought it was going to be tricky and be able to do this in my head, but I don't know what the square root of 1,000 is, so let me go figure that out. It's 31.6 meters per second. And that's decently fast for a 50-meter hill if there were no friction, complete ice, which I grew up in North Dakota, so most of the hills we went skiing on were complete ice. But that would be closer to about 70 miles an hour, which would be a terror on complete ice. Now, thankfully, there's lots of friction, and that gets some work done. It's friction against you as you're going down, so we're going to lose some of this kinetic energy as potential as you go down the hill. It makes it more reasonable as you feel. But here we set two things of energy equal to each other to be able to find out one characteristic, the velocity at the bottom.